Good evening, everybody. Myself, Dr.Basavaraju.C, working as professor in the ENC department in Cambridge Institute of Technology, Bangalore. Hereby, going to give you sessions on DFT, topic called DFT, which is coming under DSP subject. And in these sessions number 3, I'm going to discuss you derivations for frequency domain sampling. How to derive frequency sampling, domain samplings in these sessions. In my previous 2 sessions, I have given, in my video 1 and video 2, I have given, I have shown, we have discussed, how to get, why this subject we have to study, that we have seen. And in the second video, we have seen that why do you need frequency domain sampling? Last sessions. In these sessions, we'll see how to derive frequency domain sampling derivations only we'll see. Now this topic is coming under again VTU Module 1, 5th semester students or any other branch students who is really interested in DSP who can study this. Now let us see the derivations of how to get this frequency domain samples. In the previous sessions I told you, to overcome the problem of digital processing, its spectrum x of omega, we used to get x of omega versus omega, x of omega versus omega, x of omega versus omega. That means frequency spectrum versus omega using Fourier transformations, Now, here, the problem was in that case, in that Fourier transform, our input is discrete, but spectrum is continuous. This continuous spectrum cannot be processed using digital processing. We need to sample it, if you want to process using digital process. That's why what we will do, we should sample it uniformly, How to sample it? That's how, for example, between 0 to 2 pi, omega continuous spectrum. Omega is continuous between 0 to 2 pi, 0 to 2 pi, Let us sample it into 8 samples. So for example, n is equal to 8, let us say, between 0 to 2 pi. Then we'll get first sample at 0, second sample at 5 by 4 frequency, third sample at pi by 2, like that you will get 8 samples in between. Then it is easy to process the signals. Now to derive that how to get the samples, let us see at k is equal to 0 and all is coming, k is equal to 1, Now let us see how we are getting those samples. For example, let n be the number of samples considered between 0 to 2 pi, as usual, between 0 to 2 pi continuous. Let us say n samples, let us say 8 samples. 8 samples, we are considering. Now, spacing between 2 successive samples will be then 2 pi by n. For example, let n be the number of samples between 0 to 2 pi. Then what is the samples in between? Between 2 samples, what is the spacing? 2 pi by n. If it is 8 samples, 2 pi by 8. If it is 16 samples, 2 pi by 16. That's the spacing between 2 samples. That's how 2 pi by x of 2 pi by n k versus k in frequency domain. Let's see now. Now, substitute omega is equal to 0 to omega is equal to this value. 2 pi by, instead of continuous, 2 pi by n into k. Into your standard equations of Fourier transform. We know Fourier transform frequency domain conversions from time domain equation standard, last sessions. X of omega is equal to summation n is equal to minus infinity plus infinity x of n e power minus j omega n. That is what we have seen. Now substitute instead of omega 2 pi by n into k, because to get samples. Then x of 2 pi by n into k is equal to summation n is equal to minus infinity plus infinity x of n e power minus j. Instead of omega, this is 2 pi by n k n, where k is equal to 0, 1, 2, let's say 7. When k 0, you will get first sample. X 0, 0 into something is equal to, solve this, you will get first sample. When k 1, second sample. When k 2, third samples. Like that, k 7, last sample, 8 sample. That's what these equations. Now let us see how to get these frequencies. For example, k is equal to 0, this frequency, and first sample. K is equal to 1, second frequency, and second sample. K is equal to 7 by 4 pi frequency and 7 samples. 7th sample. How? This is this. Now let us see that maths again. Omega naught is equal to 2 pi by n into k. Let's say k is equal to 0. K is equal to 0, 2 pi by 8 into 0 is equal to 0. That means when k is 0 and omega is equal to 0, you will get first samples. That's what this. When k is equal to 0 and 0th frequency, at 0th frequency will be 0, first sample you will get. Similarly, second sample, when k is equal to 1, pi by 4 and second sample you should get. Maths, rest of the things are maths. K is equal to 1, then omega 1 is equal to 2 pi by 8 into 1, that is pi by 4. That means at omega 1, at pi by 4 frequency, you get second sample. That is what this. For example, when k is equal to 1, then at 5 frequency you get at pi by 4, then you will get second sample. Now it is easy. Instead of processing signals, continuous signals from here to here like this, just as passing 2 samples or 8 samples is easy, which is always processor is there to process these samples, right? That's how today's applications, today's one, we are doing so much of fastness, so many channels, which is not there in continuous time domain, continuous signals in time domain in signal systems earlier last semester, right? Now, similarly, go for k is equal to maths. Only way what is our DSP is digital signal processing is these assumptions and these equations. Most of the things are, if you are good at maths, then maths only, 90% we are talking. Omega 2 is equal to over. Similarly, k is 2, omega 2 frequency is pi by 2, third sample. That is what this. That is what this. 2, pi by 2 and third sample. K3, 3 by 4, 5, fourth sample. K4, pi frequency, fourth sample. 1, 2, 3, 4, 5. Then K5, pi by 4 and then 6th sample. K is equal to 6, 3 by 2 pi, 7th sample. Then last sample, k is equal to 7, 8th sample, you get frequency 7 by 4, 8th sample. That is what shown here. For example, that is what shown here. Now see, K3, 4th, K4, 5th sample, K5, 6th sample, K6, 7th sample, and K7, 8th samples. Now, that's all. Your spectrum continuous becomes x of omega calculated at these frequency pi. 0th, pi by 4, lastly pi by 7 by 4, pi 8. You will get all 8 samples. Then in the end, substitute all these values of k into your standard Fourier equations, which we know. Right? We get sampled spectrum like this. In these main equations, this is the main equations. This is the main equations, right? Sampled spectrum equations. If you substitute k values, you will get sampled spectrums like this. 1, 2, 3, 4, 5, 6, 7, 8. 0 to 5 continuous place, you will get 8 samples. Then 2 pi to 6, 4 pi again second period, again n number of samples, again next 8. Then 4 pi to 6 pi, again third n. Again this side 0 to minus 2 pi, this side if you get n number of samples again. Again minus 2 pi to minus 4 pi, n samples. Right? This is all you get sampled spectrum, which is ready now. You can process using processor. 1, 2, 3, 4, 5. Again lots of algorithms here. We can process easily and we can make out transmissions and receptions where exactly channel gets disturbed, channel gets mixed noise, right? That can be rectified easily. Next point is, right, now we have done this, right? We have done that now, right, for one n number of samples. But actually equations is minus infinity to plus infinity. Now see, minus infinity to plus infinity, which we are having, but we have done it for one period with n number of samples. Therefore, we have to find what number of n we have to select in between. Let's say n is the minimum number of samples. Then what we should do? We should go for a little more than half of the derivation. C is other 10% of the derivation. Determine the minimum value of n. Minimum value of n. What is the exact minimum value of n? N may be required between 0 to 2 pi or 2 pi to 4 pi or this side. Again 0 to minus 2 pi. That for that minimum to find minimum value of n, standard expression, what we should do? Let us take main summations x of 2 pi minus infinity plus infinity and divide into individual summations consisting of only n samples. We want only n samples. N. n. Then it is expanded like this. X of 2 pi by nk is equal to, derivations is lengthy, but it is easy and very, very interesting. Assumptions you have to do, like signal systems. Now, is equal to plus dash 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 dash. Let us start with negative side, negative infinity side. Let us say minus n2 minus 1, like this. Minus n2 minus infinity side I am coming. Minus n2 minus 1, let's say. Next number is 0. Between this, n samples. Then 0 to next n minus 1, second n number of samples. Again, like that it continues. For example, that's what I am doing. Let us start from minus side. N is equal to minus n2 minus 1. Minus n2 minus 1. Right, n number of samples. X of n inside is here. This is x of n e power minus j2 pi k by n by n. Right, plus then minus 1 is the last number, no? Next is it starts from 0 to n minus 1, again n samples. That's what. Summations, n is equal to 0 to n minus 1, n minus 1. Same inside, x of n e power minus j2 pi k n by n. Plus, let's say plus. Again, n minus 1 over, next sample is, last sample is n minus 1. What is the next number? Here again n. n2, last one is 2n minus 1. Then again n number of samples. That's what I am doing. Plus, n is equal to n to 2n minus 1. X of n inside, this is same. X of n e power minus j2 pi k n by n, which is standard. Plus, next sample if it starts again with n samples. Summations 2n to 3n minus 1, same. X of n e power minus j2 pi k n by n. Like that. Main summations if divided into individual summations consists of n samples. Very, very important. Next is, let me consider 0 to n minus 1 second expressions. Let me introduce one n parameter. Let me get the derivations with n samples and let me remove that assumed n parameters later. That's what I am going to do, maths. For example, the above individual summations can be represented as, let me take second summations, this one. Let me leave this. 0 to n minus 1 because n samples I want. Let me take this. What I do? Take individual samples, second summations, and use L parameter. Summations like this. Summations, second summations, which consist and include summations n is equal to 1 n parameter we include such a way that, right, n starts from minus infinity to plus infinity, and the rest of the things are same. X of n e power minus j2 pi k n by n, and introduce n is equal to ln in lower limit and ln in higher limit also. Right? How this is? For example, let me take the second summations. Introduce one more parameter with summations L is equal to minus infinity to plus infinity, and introduce ln parameter at the lower limit plus ln parameter at the higher limit, ln plus n minus 1. That's what I am doing. You see? ln plus n minus 1 instead of 0 to n minus 1. And introduce L is equal to, let me check it from minus infinity to plus infinity. Introduce this L parameter as new. In the end, when I get expressions between 0 to n minus 1, let us throw this. Right, used to get the simplified expressions. That's all. In the end, after the getting work, after getting the correct form, let us remove that. Right. So many times we used to do now in signal systems, same one. And one more important substitutions you have to do is, here next is, substitute this n inside n as n is equal to n plus ln for the simplification purpose. Let us see what happens to these summations. If I consider n is equal to n plus ln, I will get back my summations as n is equal to 0 to n minus 1 only. 0 to n minus 1. However, let me see now. For example, x of 2 pi by nk is equal to summations L is equal to minus infinity plus infinity, and your new summations becomes n is equal to 0 to infinity, 0 to n minus 1 only, minimum value of n. How I am getting this? I have shown it here. How I am getting n is equal to 0 from n is equal to ln, n is equal to ln to n is equal to 0, lower limit. How I am getting? This is, I have shown here. When n is equal to ln, for example, lower limit, then what is n? I told you n as n plus ln. That's why these substitutions. You have to remember this. N is equal to, very, very important, n plus ln. What will happen? See now, n is nothing but n plus ln is equal to ln. Ln into ln gets cancelled, n is equal to 0. Lower limit you will get. Lower limit. Similarly, when n is equal to ln plus n minus 1, upper limit. For example, n is equal to ln plus n minus 1, right? Then it is changed to n is equal to n minus 1. How? Let us see. For example, when n is equal to ln plus n minus 1, what is n? N is equal to n plus ln, which is equal to ln plus n minus 1. Ln gets cancelled. Therefore, new limits, upper limits is n is equal to n minus 1. Therefore, this is upper limit, right? Upper limit. Therefore, what is the new limits? New limits is n is equal to 0 to n minus 1. This. That I have shown it here. Is this clear? How I am getting this from this I have shown here. Then what will happen? Substitute here. L is equal to minus infinity plus infinity, n is equal to 0 to n minus 1, and inside is, instead of n, what I said is, instead of n plus ln, you have to introduce it here. That I have done. See, n instead, n plus ln, e power minus a2 pi by nk. Wherever n is there, n plus ln. N plus ln. Then expand this. Next line I am splitting this. E power minus a2 pi by nkn into e power minus a2 pi by n into kln. That's what I do. Now see, splitting these two. Right? And this is nothing but, you keep this as it is. This whole thing is nothing but 1. How I am getting? E power minus j2 pi kln by n. N gets cancelled. I am having e power minus j2 pi kl, which is equal to 1. I have shown it here. E power minus j2 pi kl is nothing but integer, which is nothing but 1. Why? Where k and l are integers, let's say. Then e power minus j2 pi kl is expanded as cos 2 pi e power minus j theta, like cos theta minus j sin theta. Cos 2 pi kl minus j sin 2 pi kl. This sign of anything, integer is 0. Cos of 2 pi kl is 1. Why? Because is, when kl is 0, you will get cos 2 0, 1. When kl is 1, 2 into 1 is 2, cos 2 pi is 1. When kl is 2, 2 into 2, 4, cos 4 pi, you will get cos 6 pi, cos 8 pi, like that. That is why this is equal to 1. Right? Therefore, irrespective of these values, this expression is 1. This expression is 1. Now 1 into this only you left now. Therefore, your final expression is interchange. Final expression is like this. X of 2 pi by nk is equal to, L is equal to minus infinity plus infinity, n is equal to 0 to n minus 1, x of n plus ln into e power minus j2 pi kl by n. Right? This is 1. Now last step is interchange this order of summation. Second as first as second, because 0 to n minus 1 I want n samples. Right? What I will do? Interchange the order of summation. Last, x of 2 pi by nk is equal to, n is equal to 0 to n minus 1 as first summation. Summation n is equal to minus infinity plus infinity, x of n plus ln as second, into e power minus j2 pi kn by n. This whole thing is nothing but, now let me, I have taken the L advantage, I am removing now. What I do? This whole thing is nothing but xp of n, periodic sequence. What is that? xp of n. L is equal to summation n is equal to minus infinity plus infinity, x of n plus ln is nothing but periodic sequence xp of n, where xp of n is nothing but this whole thing. Summations L is equal to minus infinity plus infinity, x of n plus ln, which is nothing but, this is expanded as, let's say L as L I am expanding from minus 2 to plus 2. Let us see. This whole thing is, why, when for example L is, let me expand here, L is minus 2, then what will happen? X of n minus 2L, first term will get. When L is minus 1, x of n minus 2L will get, second term. When n is 0, L is 0, x of n you will get. That means each time x of n repeats, that's all. That's why from minus infinity, n is equal to minus infinity to plus infinity. Then when n is 1, let us say, L0 over 1, then x of n plus 1, then fourth term. When n is 2, x of n plus 2n, like that it continues. What is the meaning? xp of n, where xp of n is nothing but periodic repetitions of x of n with minimum of n samples. That's what this. xp of n is nothing but periodic repetitions of your x of n with period of n samples. Like this. Periodic repetitions of x periodic repetitions of x of n with n samples with a period of n samples each time. That's why I am introducing L parameters and then checking the advantages after getting the derivations, all that modification. In the end, I am removing L parameter and I am getting the expressions, important expressions as this. Important expressions as DFT expressions in the end like this. This is x of 2 pi by nk is equal to summations n is equal to 0 to n minus 1. N samples. xp of n is periodic repetitions of sequence x of n. Right? Then e power minus a 2 pi k, 2 pi by nk. This is called DFT, discrete Fourier transform expressions. This is what frequency domain samples expressions from time domain. That means when k, that is k is equal to 0, 1, 2, n minus 1. Let us say when k is equal to 0, substitute here, you will get first sample, x0. When k is equal to 1, second sample. When k is equal to 2, third. K is equal to 7, 8 samples. Therefore, this is very, very important. This is what the derivations of frequency domain samples from the time domain sequence. Let me quickly revise quickly, right? First derivations of this. Overcome problem of digital processing, what we will do? We will sample it uniformly instead of continuous, 8 samples I want. Then now what I will do? N sample now I will consider and I will substitute omega as just omega is equal to 2 pi by n into k. Then when k is 0, I will get first, k is 1 second, k is equal to 7, 8 samples. That's what I have done here. K is equal to 0 to like 7 samples, 8 samples. Then afterwards, substitute that into equation 1, we will get sample spectrum. Then after that, what's the minimum value of n required between 0 to 2 pi or 4 pi to 6 pi? Then what I will do, I will take first main summations, divide into number of summations, individuals. I will take second summations, I will introduce one parameter n. N from minus infinity to plus infinity, you know now why. Then add ln parameter in the lower limit and upper limit just to get simplifications. Then substitute your inner n as n plus ln, simplifications. Then n plus ln, you will get 2 terms here. Then one is expanded as, and how I am getting these two, I am expanding here. Then expand these two, this gets equal to 1, how I have shown here. Then in the end, interchange summations. You will get expression. This is nothing but periodic repetitions. xp of n is nothing, this is nothing but periodic repetitions. In the end, how this is repeated, x of n is I have shown here. That's all. And in the end, you will get frequency spectrum